Okay everyone, in this part with the help of two small animation, I will try to clarify two things. Why data path should be greater than clock skew. So if you remember, we have discussed in the previous part that data path delay should be greater than the clock skew. So we will discuss that part here once again with the help of the small animation. And second thing is how your design can be functionally wrong because of the skew. So we have discussed both of the things in the previous part also, but here I will just try to show you some animation. So maybe that can help you just for more understanding. So we are talking about the design. So in this right now we are talking about the design where the clock skew, is greater than the data path delay. So when I am saying the data path delay, that means the clock to Q delay and Q1 to D2 delay. Now I just applied initial value as the D2 is a 1 and Q2 as a 0. So basically right now the situation is that FF2 is waiting for the clock edge. So the moment it will get the positive clock edge, it will transfer this one from D2 to Q2. Similarly, there is a initial value at the D1 and it is also waiting, FF1 is also waiting for the positive clock edge. Now let's apply this positive clock edge. So I just applied the positive clock edge here. From this point to this point, there is only one buffer and it is the same. So this path is common for the clock 1 and clock 2 both. So this delay is added in both the clocks. Now from this point, the clock is going to divide into the two part. So now just see the animation. What is going on? Now clock divided into the two parts, and you can see that as soon as FF1 get the positive edge, 0 shifted to Q1. Just see it once again. So as soon as this got the positive edge, is shifted to here. And as per the delay between the Q1 and D2, it will reaches at the D2. So as you can see here, as you just saw here, that 0 reaches to D2 point before even the positive edge reaches at FF2. Just see it once again. Just concentrate on the clock, this clock which is reaching here, and when this data is going from here to here. So it is overridden. Now it reaches here. Says there you can see that 0 is a D2 point before even the positive clock edge reaches at FF2. So obviously it will override the previous data which is present at the D2, which was at 1. So the 1 was replaced by the 0. The moment positive edge reaches at FF2, it will see 0 and it will capture 0 and transfer that to the Q2. So our expectation was that 1 was present here, and our expectation was that this clock edge should capture that 1 and it should transfer that 1 from D2 to Q2. But what happened, because this delay is very less, that our data, our 0 is shifted from is transferred from D1 to Q1, and from Q1 to D2 in a very less time, and even it is before this positive edge reaches here. So I'm sure now you got my point, which I was just trying to explain you even in the last part, that what about the functional error. Our expectation was one supposed to reach here, but just because of clock skew is greater than the data path delay, we got the final result 0, and which is a functionally wrong. Now let's see this case where the skew is less than data path delay. And just for that understanding, what I did, I just added two extra buffer here. so that you can understand that okay, this path has a greater delay uh, in comparison to this path. Now, like we did in the last the previous animation also, the initial value we applied here is 1 and 0, and our expectation is that 1 supposed to pass here. We have applied 0 at the input of the FF1. Now we are going to apply the positive edge. The moment, same thing, the positive edge still here, everything is same. Now from here I am applying here, this reaches here, 0 transferred here, this edge reaches here, and this one transferred here. And if you just want to see that this positive edge reaches at FF2 earlier, then the 0 reaches at here. Just check it once again. 0 is here and clock take to 1 and 1 is transferred to here. So just see it once again. Positive edge reaches clock CLK1 and CLK2. The one is captured. So this one is captured and shifted to output, and after that this 0 reaches here. So now for the next stage, this for the next edge, this will be our initial value and there will be some value here. So FF2 capture the 1 at the first clock edge and the 0 it will capture in the next clock edge. Now at least there is no issue from the functional side. I'm sure that now you got the importance of the statement when I made this statement that data path delay should be greater than the skew. So I think now you got that importance that if we want our design supposed to be functionally correct, then this condition should always be true. So now at least there is no issue from the functional side. So if you will make this condition, if you satisfy this condition, there will be no issue from the functional side. But still there are many other issues, and basically those are related to the hold violations. And in the next part we will discuss that how hold violation has a dependency on the clock skew.